Hello guys, hello everyone. How are you all? I think hope you are doing good. So in this today's video, I have brought you some very important concept. Okay, so that is which is related to the graphs. So that is I'm discussing about the graphs in kinematics. So first of all, what is meant by this kinematics? See, kinematics is the branch of physics that will deals with the study of motion of the objects without considering the force that cause the motion. Obviously, is if any object is in the motion, the force is applied on that, right? But we are not actually bothering about how what force is actually acting on it. We are just bothering about its motion of the body, right? That is what is kinematics. Simply like it describes how the things will move, okay, not why they move. Okay, so it mainly we will study about some distance, displacement, velocity, accelerations, speed, time. Everything will come under this. Okay, so let us discuss first before going to the graphs, let us understand what are all these terminologies. Okay, so these are all the terms that we are gonna know about in this today's video. First, let us know about the basic terminology, that is the distance, right? So distance is nothing but a total length or total path covered by an object, okay, irrespective of its direction. Hence it is called a scalar quantity. I think you know about the scalar quantity and vector quantity. Scalar quantity is nothing but which is concentrated on only magnitude. It does not depend upon the direction, whereas vector quantity means where both the magnitude as well as direction is considered, my dears. Okay, so next is about displacement. Okay, so displacement is nothing but it's the shortest straight line distance from the initial position to the final positions of the object, where initial final positions is concerned a lot, as well as it's a shortest distance. Okay, and also this displacement is a vector quantity, my dears, which considering both magnitude and as well as the directions. Okay, so next let us come to the speed. So speed is nothing but it is the distance per unit time. That is, I can also say it as the rate at which distance is covered. That is nothing but how much distance is traveled in how much time. That is speed distance divided by time itself is a speed. Okay, so next coming to the velocity. Velocity is nothing but the rate at which displacement will changes with respect to time. That is rate of change of displacement. Displacement divided by time is displacement. Next is the acceleration. See, acceleration is nothing but the rate of change of velocity. See, velocity is nothing but a rate of change of displacement. Acceleration is nothing but a rate of change of velocity. This is how these are interconnected with each other. So I think hope you understand this basic thing. So now let us move on to the graphs. I think hope you can see all the things which I have written here. So I have taken the type of graph. So obviously graph means we'll be having the x-axis and y-axis, right? So in x-axis I am taking all the common thing, that is time. With respect to time we are calculating. Okay, so in y-axis I am taking the different terminologies like distance, velocity, accelerations. Okay, so let us see the different situations here. The first thing which I'm taking the scenario is rest. When the body is at rest, what will be the distance versus time graph? So I've already said this is a distance, okay, and this is a time. Okay, see, with respect to time, object is at rest means it is not at all covering any distance. So therefore it will be straight line that is parallel to the x-axis. This shows that it is like it is at rest. Okay, so next, if I consider the velocity time graph, similar pattern you can see, but you just write it down like this because it is not covering any distance, and velocity is also like rest is nothing but it is not having any velocity. Okay, almost zero velocity like that. Okay, acceleration time graph also you will write the same thing, because at rest means if no distance means no velocity, no velocity means obviously no acceleration. So this is the graph which is at rest. Okay, when the body is at rest. So now let us move on to the next situation. So next I am taking the constant velocity. See, at constant velocity is nothing but a velocity is in a same pattern, like 5 meter per second or kilometer per hour, like that. Okay, it is not at all changing throughout. So therefore constant is nothing but a, for with respect to velocity time graph, obviously it will show the straight line because it is constant, right? Therefore, so but if I consider the distance time graph, what will happen is here the distance will increases, okay, but it is constant, not like any no curviness, no, a straight line you must draw, because this distance is constantly increasing means your velocity is constant. Okay, this is increasing, okay, means this velocity is constant, it is like that. Okay, so this is about the velocity time graph. But if what if I say about acceleration, this is very important, my dears. Remember, if constant velocity is there means acceleration will be zero. Acceleration is zero. Acceleration in the sense there should be a change in velocity, right? What is mean by acceleration? Change in velocity with respect to time, right? But there is a constant velocity means obviously there is no acceleration, therefore it is almost on the x-axis, almost x-axis only. Okay, so which is representing that it is a constant velocity. Okay, see, this is how the graph will look in different okay, distance time graph, velocity time graph, acceleration time graph. Okay, see, one more important thing I have to say is, see, I'm saying which graph it is, and then I'm writing the graphs. Okay, but similarly I'm if I give the graphs, you must be able to identify it reverse. That is, it is distance time graph, it is showing constant velocity, it is showing the rest body is at rest, constant acceleration it is showing, like that. You should know reverse also. Now I am saying this is the problem in like in this direction also, that is, if they give the graph, you must identify which condition it is, or if they give the condition, you must able to draw the graph. Okay, so now let us move to the next. Now let me take the situation of the constant acceleration. So obviously constant acceleration should be there means let me write first acceleration time graph, which is very easy. Acceleration is constant, that's it. Okay, if acceleration should be constant means velocity should be increasing in a same rate, right? Velocity should be increasing first of all, then only your acceleration is at constant. Okay, so velocity is increasing. So velocity is increasing means it is not constant, then obviously your distance should be also increasing. But how? It is not constantly at constant rate, it is not increasing. Okay, like suddenly or suddenly it will increases. Okay, at some point of time suddenly it will increases, it is not at a constant rate. Okay, because if you want to get like this constant velocity, this is not a constant velocity. Okay, it is increasing velocity, your distance should be like this, it is should be varying distance. Okay, that is a distance time graph. Okay, so this is velocity and acceleration is constant. So this is about constant acceleration. Now the next thing is constant retardation. See, retardation in the sense velocity is decreasing with respect to time. Okay, so constant retardation and acceleration both are same. Okay, but both are also velocity with respect to time, but this is velocity increasing with respect to time, but this retardation is velocity is decreasing with respect to time. However, constant retardation in the sense acceleration time graph is showing the constantness, that is a parallel with respect to x-axis. So if I consider the velocity time graph, obviously it is retarding in the sense it should be decreasing. Okay, how it is showing you like this straight line, you show the straight line towards downwards towards the x-axis you have to show, because it is decreasing, right? That is why the graph will come like this. Okay, and similarly what graph you get like this in the constant acceleration for the distance. Now obviously it is retardation means velocity should decrease, in the sense distance is also varying, that is like decreasing. So that is you have to show like this type of graph. Okay, my dears, so show like graph like this. Okay, so I think hope you understand about this. So now if I consider the increasing acceleration, okay, so remember increasing acceleration only increasing means how it will be. Say velocity is increasing means you will get a straight lines like this, right? So similarly, if the acceleration is increasing, in the sense you will be having the straight line for this, okay. If you are having the acceleration straight line, obviously its velocity will be what it is, increasing, but what, not at a constant rate like this it will be showing. Okay, if velocity only is like this, then your distance, the lower than this, will be still more changing, like sudden or abrupt change, what we will say, it will be shown by this distance. You have to show your broader curve here, a little like towards some y-axis, however, okay, we have to draw like this. So yes, my dears, I think hope you understand the graphs which I have drawn here. So for the bonus, okay, I am giving another one graph, okay, with respect to retardation. That is, retardation is also called as negative acceleration, my dears. Remember this one, okay, negative acceleration we will call it one, okay. So I just give you another one graph, that is here. This is the another graph I am giving, like this type of graph. You will usually you just see this type of graphs. See this graph, what it does means is, the object is there, no, it is having initial some velocity, okay. So it is not having initially, it is not zero velocity. See, if I am starting from the origin means, my dears, it means that, see, every questions, you know, they will not mention what the things are given in question only, okay. Some questions, you know, they will give some graphs, okay, and they will don't say that the initial velocity is zero. You must identify the graphs to identify the velocity zero or not. See, in this type of graphs, origin, okay, it is starting from origin means initial velocity will be zero. But in this type of graphs, my dears, so initial velocity is not zero, the object is having some initial velocity, okay. After some time the object is coming to the rest, okay, that is why it is there here, okay. So this is showing the velocity versus time graph, that is nothing but a v by t, the slope. What is meant by slope? That is y by x, right? Y by x is nothing but a slope. So what is y, that is velocity. What is x? That is time. What is v by t? That is velocity by time. That is nothing but a what? Acceleration, right? But here it is not the increasing, okay, velocity is not increasing. I already said decreasing velocity with respect to time is nothing but a retardation, right? That is also is nothing but a negative acceleration or retardation, right? So now we are having a retardation, that is the object is initially having some velocity and it is having some negative acceleration, that is retardation, and finally with respect to time it is coming to the rest, okay. That is the meaning of this graph. I think hope you understand about the meaning of this graph, okay. This is a bonus graph that I have given you. You can take the screenshot of this graph. So that's all for this today's video. I think hope you understand the content of this today's video. So meet you in the next video. Until that, stay tuned.